All right, everybody, the last video for chapter 5. Okay, so the Illinois River flow in cubic feet per second is shown in the month of May as the rainy season ends and the level starts dropping. All right, so just like the preceding 4 chapters, in the last section, section 5.2, we gave you an X value, you found the corresponding Y value, and it wasn't too bad because it was like all the other sections. Now in this section, the last one of the chapter, we'll give you a Y value, you go find the corresponding X value. All right, that sounds good. Okay, so I'm going to change up some numbers here. We'll just call that 750. Maybe we'll call this 500 even. Call this 350, and that should change things enough. Okay, so it says start off with regression. Okay, 2 decimal places. Well, that's nice. That's not the hardest thing in the world. And so we'll go stat, enter, and I'll pause the show. Okay, so we got that. And so all my data is plugged in there. And again, I changed up some of the numbers there just so that, I don't spoil the surprise when you get to this problem on the homework. Okay, because I mean, hey, nobody wants their presents to be opened up early, especially by somebody else. That's what we're avoiding. Okay, so I'm going to go to stat over, and oh wait, no, not that. Let me quit out of there. All right, stat over, and then I want to go down to logarithmic regression because that's what they asked me to do. Go find the best logarithmic equation or model to represent the data. Okay, so then I'm going to go down. Hey there. I'm going to go down to calculate. Yeah, the video's not on. And there's my equation. So now I'm ready to write that down. I already forgot. Was it 2 decimal places? I don't remember. Let's see. It was. Oh my goodness. That was probably just a good guess rather than memory, but whatever. So the equation is going to be y equals 1911.78 minus 579.74 multiplied by the natural log of x. Okay. So there's the equation. So yeah, so that's not new. We did that in the last section. Part B and C, that's the new stuff. So in both cases, they give us a Y value, a level of the river, so 200 cubic feet per second, or 1,000 cubic feet per second. And so they give us these Y values. They say, go find the X value. Go find the day when we expect the river to be at that level, which is kind of nice if you have those expectations, if you're working this job, because then if you go out and actually check on that day and it's significantly different from what you expected, then you say, whoa, okay, why is it different? And then you investigate and you figure out, oh, hey, we got more rain than we thought we would, or less, or there's something else going on, that might be really important to know about sooner than later, so that the town downriver doesn't get washed away or something. Okay. So that's the idea. Now, again, instead of using their data, how about we use our own? Let's go. That was 201,000. I don't know. Let's go maybe 500. Okay, or yeah, we'll start with 500, even though it's pretty obvious. Okay, I'll do 2 of these. So 500 cubic feet per second. Well, oh no, we already got that. Okay, well, that's dumb. Let's try 525. Okay, because that's not actually on the list. Okay, so 525, that's in between these 2 here. So we would expect to get a date somewhere between day 10 and day 11. So like day 10 and a half or something. All right. So let's see how to actually do this. Okay, so we're going to pull out our scratch pad here again, so we can kind of see what's going on. All right, so if we use 525, again, that is a Y value, so I'll plug that in for Y. And I write all this fun stuff out. And blah, blah, blah. Okay, now, what do we do to solve for x? Well, the first two steps are things we've seen in the past. Um, we're going to first subtract away the 1911.78 from both sides. So nothing, real mind-boggling there. However, here, and I'm just going to use my handheld. Let's see what we got here. So we got 525 minus 1911.78, and we get negative 1386.78. Now, the fact that we just got a negative number, that might make you feel a little squeamish, but it's okay. All right, because that's not our final answer. We have not yet solved for x. Okay. That's a 7. I know, I'm terrible at my penmanship. Okay, so now we say, hey, this guy is being multiplied by the log function, so we'll do the opposite of that. We will divide by negative 579.74, and those will cancel. Negative 579.74. Okay, so we got that cool thing. And I'm going to go to my calculator, and I'm dividing a negative by a negative. So, hey, guess what? Negative's going to go away. Isn't that wonderful? And we're going to get, now on my calculator, I did not round this number off. Okay. Actually, well, no. Okay, there was no rounding to do. Sorry. Okay. But, okay, so now that I divide by this number, I'm not going to round off that on my calculator. That way it stays more accurate. I'm only going to do rounding when they tell me to or at the very end of the problem. Okay, which I guess is when they tell me to. Anyway, so I do that division and I get about 2.39. And then that equals ln of x. Okay, so far, I haven't done anything in this video that's new. Okay, so be aware of that. Nothing in this video so far is new. This next step is where the new stuff starts, and it doesn't last very long. Oh, hey, Zoe. My dog just wandered in. In a traditional algebra class, I would go into considerably more detail to explain this next step. But suffice to say, at this point, you are going to convert this logarithmic equation into an exponential equation, and it becomes e to the 2.39 equals x, and it gets x by itself. It's not magic. It might look like it, but it's not magic. Okay. Oh, my dog left. What the heck? She betrayed me again. All right, so to get from here to here, every time what you're going to do is you're going to do e raised to this power here every time, and then that'll equal x every time. And again, I'm going to do one more example of this in just a few moments. Okay, and now x is isolated, so now we can just plug it into the calculator. Okay, you might be thinking, yeah, well, I've never done this before. That's okay, I'm going to show you, right? So notice right above the ln key, it says e to the power of x, e to any power you want. So you can go blue, and then and that gives you e to a power. And then you just type in whatever power you want, okay? And that was the 2.39. I'm going to type in the entire number. Should have done this on this calculator. Okay, and I'm going to type in the entire number just to be more accurate. So it gives me that. And let's see, whoops, where's the book? Book is here. It says we want to go to 1 decimal place, the nearest 10th. Okay, so that would be 10.9. 10.9 what? Day 10.9. Okay, I estimated 10 and a half, 10.5. I knew it'd be between 10 and 11, but okay, so day 10.9. So, I mean, practically day 11. Okay, practically May 11th. Okay, whatever. So that's how you would do that. There is another key you could use if you prefer it. It doesn't really matter. Notice right above the division sign is E. It's that same E. I could go blue E, but then I have to say raised to the power of, and then I type in the exponent. It does. It's like one extra keystroke or something. It's not a big deal. Now notice there's a third E right here, right above the sign button. Now that's a capital E, and it's in green. So if I go green E, that's something different. That is totally different from this E. This one is just a random placeholder for any old number you want to put there. But the lowercase e, that's an actual number. Okay. The lowercase e is approximately 2.7. It's like pi. It goes on forever and it doesn't repeat. If you go a few more decimal places out than the calculator is showing, you'll see that okay, it keeps changing all over the place. But yeah, lowercase e is what we want. We're not even going to worry about the uppercase stuff. Okay, on the calculator. Okay, so we got that, and it was super cool. So what about? Let me do a little bit of this, kind of clean things up just a wee bit. All right. So what if we want to do? Get rid of that. And oh wait, yeah, I want that. Okay. Let's do something like 250. Okay, for our cubic feet per second. Well, 250 is a little bit lower than the 302 here. So we're probably going to go a little bit further down our month. So I don't know, month like day 18 maybe. Okay, is what I'm guessing for our answer. Okay, so we're going to see what's going on at 200. When do we expect to have 250 cubic feet per second? Again, 250 cubic feet per second is a y value, so I'm plugging it in for y. All right, that's very important. If I plug 250 in for x, then I'm saying, oh, the 250th day of May, which, I mean, you could figure that out. It would be like probably, into the following January. But again, that's not what we mean. So we're not going to do that. Okay. So once again, we say, well, I've got something being added or subtracted to the x, and then I've got something being multiplied by the x. So first, like we've learned in the past, I'll subtract this from both sides. Okay, 250 minus 1911.78, and that gives us negative 1661.78 equals negative 579.74 multiplied by ln of x, or the natural log of x. All right, so now I'm going to divide both sides by negative 579.74. Okay, that's super cool. Okay, calculator time. So divide by negative 579.74. Okay, and I get 2.87-ish equals ln of x. And now I'm going to do e to the 2.87 equals x. And so I'm just going to do my handheld calculator. And I get to one decimal place, day number 17.6. So just a little over halfway through day 17. Okay, a little more than halfway through the May 17th. So now, again, these models are not going to be perfect. So if you measure, if you measure what's going on a little bit after noon on day 17, a little more than halfway through day 17, and you don't get 250 cubic feet per second, but you get like 260, that's probably not going to be a big deal. Okay, you're probably like, yeah, okay, close enough. Now, if you got like 350, you'd be like, whoa, whoa, whoa. Okay, that's more significant. Plus, not only that, you got to deal with the fact that, okay, if I'm significantly off, did I measure the flow of the river correctly? Okay, maybe I need to calibrate my machine or something. So anyway, there's all kinds of things you can think about. But that is how it is done. Okay, and that would have been our answer for 250 cubic feet per second. All right, and that's the end of the chapter.